Okay, so this is 11.1 and 11.2, and basically we're talking about rational expressions which are like fractions except for they have polynomials in them. And with a rational expression, when you go to simplify the rational expression, you need to keep in mind that because it is a fraction, like any fraction, you can't have a denominator of 0, which is why we need to find out what our excluded values are before we can do anything else. So the first thing I'm going to do is, if you look at this example at the bottom, down here, I'm going to simplify it as much as I can. So on the top there's nothing I can do, it remains as x minus 1, but on the bottom I can factor out a 5. So my first step is to simplify. My second step is going to be to find my excluded values. And the way that you find your excluded values is you take the bottom, your denominator, and you put it equal to 0. So I would divide by 5, and 0 divided by anything is 0. So basically the 5 kind of just cancels out. And I'm left with x minus 1 equals 0. Sorry, I don't know why this is doing this. And then we are going to add the 1, which means x cannot be 1. That is my excluded value. X cannot equal 1. Oh my goodness. And what that means is that if I were to plug in 1 for x, it would give me a 0 on the bottom of the fraction, and that would make it undefined. So I have to find out what values would make it undefined and eliminate those values, because I don't want to use those values as a part of my solution. My last step is going to be to go ahead and continue to simplify the fraction. So really the first step is like factoring, and then the last step is simplifying. So since this was my original, once I factored out everything, I can now cross out what I have in common, and that leaves me with just 1 over 5. So just to recap, my answer is 1 over 5 with an excluded value of 1. Okay, so when you are multiplying and dividing rational expressions, we're still going to look for excluded values. We're still going to factor as much as we can, but now we have an operation to consider, which will be either the multiplying or dividing. So if you look at the first example, there's nothing to factor here, so I'm going to go straight to finding my excluded values. And basically here, if I were to put either a squared or a cubed equal to 0, it would just be 0. Since it's a monomial, I know my excluded factor is going to be 0. So I cannot have 0 as my a, right? So now I can go ahead and multiply. So I'm going to, if I can reduce anything I will, which I can't. So I'm just going to continue to multiply, and it becomes negative 12 over a to the 5th. Okay, look at the next one. Same thing. I get my excluded values. So for this one, because it's a monomial, it's automatically going to be 0. And for this one here, I put it equal to 0, and it's going to be negative 3. So my excluded values are 0 and negative 3, because if I plug those in, it will give me a 0 on the bottom of the fraction. Now I can continue to multiply. I have nothing that can be reduced, so I'm just going to put them next to each other. X minus 7 times x minus 5 over x times x plus 3. Okay, go ahead and try B at the bottom here. So go ahead and check your answer. Okay, so this one is a little bit more complex because it has factoring. So before, our first step was going straight to excluded values. Now we have to make sure that we factor first. So if you notice in the first fraction, we have x plus 5. And then down here I can factor out a 7. Now I look at my second fraction. The top, 14x, there's nothing I can do. But on the bottom it does factor into two parentheses. My signs are different. Factors of 10 are 5 and 2. Oops. And we just have to check to make sure. So 5x minus 2x gives me 3x. That works. So now I'm going to look for my excluded values, because remember, your first step is to simplify or factor in this case. Second step is excluded values. And then third step is to continue to simplify or reduce whatever you can reduce. So my excluded values would be over here. If I put this equal to 0, I would get x is not equal to 3. If I put this equal to 0, I get x is not equal to negative 5. And if I put this equal to 0, I get x is not equal to 2. So now I can reduce or simplify. I have an x plus 5 here and x plus 5 here. Those cancel. I can reduce the 7 with the 14. And that leaves me with 2x on top and x minus 3, x minus 2 on the bottom, with my excluded values of 3, negative 5, and 2. So this is all my answer. Okay, go ahead and try to do this one. Remember, this would be over 1. Okay, check your answer. Here is your fraction, and here is your excluded value. Okay, next we look at division, and it's very similar to multiplication, except for just like a regular fraction, you have to do keep change reciprocal or keep change flip. So I'm going to factor everything I can factor. So up here I have a difference of squares, x plus 5, x minus 5. On the bottom I have a GCF of 4. Okay, the top here doesn't change. And then here I can factor. Now, since it is division, I'm going to change it to multiplication by doing the keep change flip. So this one is going to stay the same, keep. Oh, shoot, let me fix that. So x plus 5, x minus 5 over 4 times x plus 7. Change to multiplication and flip the second fraction. Okay, so now I'm going to find my excluded values. I cannot have negative 7 or 5. And then I'm going to go ahead and reduce whatever I can reduce. So I have an x plus 7, I have an x minus 5, and that's it. So I'm left with x plus 5, x plus 2 on the top, and just a 4 on the bottom with my excluded values of negative 7 and 5. So go ahead and solve the next problem. Okay, so check your answer. Alright, so the last thing is a complex fraction, which is another way to do division. Don't let it make you nervous just because you see a fraction within a fraction. Basically, you're going to take this middle line right here and you're going to extend it. And that's your division line. So you have your top fraction divided by your bottom fraction. And then you would set it up like any other division problem. So 1 over x minus 2 times x squared minus 4 over x plus 3. Now we did keep change flip, so now it's a multiplication. I find my excluded values. X cannot equal 2 or negative 3. Here I can factor because that is difference of squares. And then I can reduce or simplify. So I'm left with x plus 2 over x plus 3, and my excluded values are 2 and negative 3. So again, just elongate this bar. That's your division line. It's the top fraction divided by the bottom fraction. Rewrite it horizontally, and then just change it into a multiplication problem. Go ahead and try the bottom example. Okay, go ahead and check your answer.